Так.
Микола Вікторович, будь ласка.
Добрий день, шановні друзі. Я радий зустрічі у наш буремний час, коли рашисти топчуть нашу землю, окупанти нищать міста і села, зухвалий ворог знущається над мирними жителями. Україна має багато друзів. Нас потужно підтримують англічани, поляки, американці, литовці і багато-багато інших. Ми маємо багато друзів, колег. Ми впевнені в наших Збройних силах і в швидкій перемозі. А ми на своєму професійному рівні мали би підтримувати дух і демонструвати високий професіоналізм. Ми сьогодні маємо чудову нагоду поспілкуватися із нашим колегою із Америки, Олександром Карпом. Ще раз всіх вітаю. Бажаю цікавої, плідної дискусії і передаю Олександру Володимировичу керівництво. Олександр Володимирович, керуйте далі.
Дякую, Микола Вікторович. Я хочу представити нашого сьогоднішнього гостя. Я буду робити це українською, тому що більшість присутніх із України. Sorry for Janos. I will speak Ukrainian because the most of participants are Ukrainians.
Sure, naturally.
I will say some words about Professor Karp. Професор Карп, Alexander Karp, це керівник магістерських програм Teachers College of Columbia University. Він знаний науковець, автор сотень статей, підручників для школи, наукових монографій. Його інтереси досить різноманітні. За його редакцією недавно вийшла, наприклад, монографія щодо особливостей розвитку математичної освіти в Східній Європі за останні 30 років. Ми мали честь співпрацювати з Александром Карпом при написанні цієї монографії. І за сприяння професора Карпа в цій монографії вийшла стаття, яка стосується освіти України. Авторами цієї статті були Валентина Григорівна Бевс, Василь Олександрович Швець, Ольга Іванівна Матяш, Олександр Володимирович Школьний. І в цій монографії нам вдалося багато чого донести і розповісти про українську освіту за останні 30 років. Ми щиро вдячні професору Карпу за цю можливість, сподіваємося на подальшу співпрацю, як особисто з ним, так і з Teachers College of Columbia University. І на цьому напрямку у нас є просування. Недавно ми подовжили угоду із Teachers College, пролонгували на наступні 3 роки. І можна сказати, що і ця сьогоднішня доповідь, вона відбувається і в рамках цієї угоди між нашими університетами. Сподіваюся, що далі ми напишемо ще багато цікавих статей. І я сподіваюся, що Фулбрайтівський комітет затвердить заявку Александра Карпа. І зовсім скоро ми побачимо його в Україні, в Києві, в наших стінах. Він прочитає ще не одну лекцію для наших студентів, ми матимемо змогу з ним спілкуватися і далі. В принципі, я думаю, що цього вступного слова цілком досить. Я надаю слово пану професору Александру Карпу для проголошення доповіді. Доповідь буде англійською мовою, але з українською презентацією, як ми вже і попереджали вас. Дякую всім і передаю слово Александру Карпу. Будь ласка.
Дякую. Thank you so much for inviting me, and thank you so much for all your kind words. And let me 1 second, as usual, technology is the most challenging thing. Oops. Okay, so Okay, so yes, I will speak in English, and there will be a translation in Ukrainian. So I think in this or that way, it will be possible to follow. I will speak about problem solving, but I feel that, that I need to start with something else. And I would like to cite the words of a hero of my favorite novel of Vasily Grossman, that every day of life of our state is impossible for fascism. Fascism has no choice, either eat us up or disappear. And I would say that today it's about Ukraine, and Ukraine is on the front line of a fight against fascism. And I would like to say that absolutely every person whom I know thinks today about Ukraine, feels compassion for Ukraine, likes to help to Ukraine, and admire Ukraine. Slava Ukraini. Well, after saying this, I think we can move to the theme of the lecture, of this presentation. And I will talk about problem solving. And given that problem solving is a huge theme, I need to say what will be here, what will be discussed. So I will start with discussion of some theoretical constructions and words, but just defining what we're talking about. Then you see my major interest, let's say last years, is in history of mathematics education. And I will tell a little bit about the history of problem solving. Then I will just list some, of course, not all, but some, in my opinion, most important contribution to the field. Well, world contribution, which, if you wish, you can say Western contribution, although generally speaking, I'm not very fond of this using Western, Eastern. It's not always easy to say what is what. And of course, the most important thing, why problem solving is so important. And then I will move to whatever you want. You can say more theoretical, or you can say more practical issues of the work with problems, and basically we'll speak a little bit about collections of problems, because I think that's where both practical things, practical teaching, and more general theoretical today should be focused. Okay, now question number one: what do we mean by problem solving? Well, I can't help but cite National Council of Teachers of Mathematics, NCTM, which is the leading American mathematics educational organization. And all documents of this organization are always cited. They're extremely influential. So what they wrote problem solving means engaging in a task for which the solution method is not known in advance. I'm afraid that what problem solving in this meaning is not very easy to translate in other languages. And that's why, because when you say problem solving, the words themselves do not distinguish which problem. The one for which solution method is not known in advance and the one for which solution method is known in advance. So sometimes people add something, say they're using the terminology like solution, a problem solving of creative problems, or something like that, adding the word to make it more clear that it's not any task, but specifically such a problem that solution method is not known in advance. In this presentation, I will use the language of problem solving, meaning problem solving not for any task, but specifically for this one. Okay, immediately we would like to have some specification. What do we mean? Say you ask 2 times 2. Is it problem solving or it's doing exercise? The word exercise so is used as opposed in this terminology, not in life. In life, student can say, oh, I got 15 problems, or can say, oh, I got 15 exercises, or I got 15 tasks, without distinction. But in this research, people are using problem for, we can say, creative solving and exercises when it's just more routine activity. So 2 times 2, what is it? And the answer is we do not know. It depends on the audience. If I give this task for our audience, okay, guys, it's basically, we can say exercise without any doubt. Probably even less than exercise because it's an act of memorization. Everybody knows that. But if you give this to, say, 3-year-old, it clearly will be a problem because how to do it, it's not that the child necessarily knows this. So, very important thing which we need to understand. Problem solving is a sophisticated concept, and it's not just purely mathematical. It's psychological, it's social, it's educational, and so on. So when you simply look at the problem, something which is very obvious, but sometimes necessary to repeat. When you look at the problem, you cannot, at the task, you cannot say, is it problem solving or it's doing exercise? You need to know much more about students, about the solvers. Okay, one parenthetical note. If in research works, you see some discussion how in different countries students demonstrate their creativity when solving problems are given and discussion of their creativity. This made better, these were not that good, and so on. So sorry, it means that methodologically these papers are not strong. Or if I basically put it here, that's not a scientific work. Because looking at the problem, you cannot say, what is it? I had an experience looking at some exams in some countries and saying, look, it's beyond any level. How can they do it? It's fantastically difficult. And people from the country laughed and say, look, we're doing this problem for half of a year before the exam. Of course, everybody reproduces it. What's the problem? So it's much more sophisticated. A little bit more and very important for us. As I presented, and as it is presented in many books, problems are opposed to exercises. In reality, it's not that simple. And some psychologists wrote that there is a continuum. It's a much more, it's not that discrete. Of course, you open some collection and professional would say, oh, no, now we have problems on systems of equation. You will say, this is X, this is Y, and then you solve the system, that's it. But it's not how it is for a child, at least at the beginning. For a child, they are different. This problem is about apples and pears, this one about cows and sheep. Us understand it's X, that's Y, that's it. But no, it's not just a process of direct memorization and application of it. There is some element of doing something what never was done before. And our goal of teachers very often is to make it automatic. Yes, you can say that very often teacher is basically working on making exercise out of the problem. So yes, we want students to do some things automatically. That is, become professional in some sense. But it doesn't mean that they are automatically exercises at the very beginning. We need to understand. Okay, as I said, I love history. So let's talk a little bit about problem solving. Excuse me, problem solving in secondary school. This portrait is said to be a portrait of Fibonacci, Leonardo Pisansky, Leonardo of Pisa, who basically there is a favorite story. Everybody loves to tell a story, how yet whatever 800 or 900 years ago, Fibonacci in front of the Emperor Friedrich II had to solve some problems, so competing with somebody, he prevailed, and look, so they had problem solving. Of course they had problem solving, but it was not in a secondary school. So the story we need very clearly understand that all these beautiful stories are not about problem solving in school. It's simply irrelevant. Of course, people did problem solving all the history, I would say, including prehistoric time. You simply cannot operate. I'm here given an example of hunting. If you are simply doing always the same, you will not be a successful hunter. It wasn't mathematical problem solving. Of course, it was problem solving. Yes. What is important that in school for centuries, the goal was not in this problem solving, but rather in reproducing some wisdom. That was the goal. I'm sorry. That was the goal of the I'm sorry that something doesn't work with another device. We'll just turn it off. So that's simply not about that. Some people thought that the goal is to teach wisdom and basically reproduce this. Well, not only that. You can say that since some moment, there were, let's call it, practically oriented schools. It's a very interesting issue. Just currently, I'm doing some research about these things and have a temptation to tell more about these things. So what they did, what kind of practical activities, what kind of problems were in these practical things? So of course, they taught how to change currency from one system into another. Merchants needed, they taught this. They taught how to find areas. Of course, it was necessary. They had some problems in navigation. They taught it. All that were, of course, exercises. If you look at these textbooks, you will see of 16th century or 15th century, you will see that they explain in situation like that, do that, period. That's it. So again, not problems. Now, example, much more recent example, not 15th century. So very famous person, of course, known to people who basically, I'm looking for a good word, sufficiently mature, let's say like that, because it's a textbooks which were in use for a very long time. Textbook of Kiselev, famous textbook of Kiselev. So if you take this indeed great textbook and analyze what kind of problems are there, you'll find that, say, in the section on areas, there are the following problems. 8 problems on proofs, 6 problems on calculations, and 19 problems on constructions with compass and straight edge. First of all, it's just if you compare with any current textbooks, you'll say, look, there are much more tests for entire section. It's not for one piece, no, it's for entire section. And the very first problem on construction is construct 2 straight lines through the vertex of the triangle so that its area will be divided in parts, areas of which has a ratio m to n to p. Look, you cannot do this as a first problem. It's extremely difficult if you just think first problem. So there was no idea, even with Kiselev, and Kiselev, it's already kind of revolutionary text with a lot of new ideas. But even then, these problem things were not extremely strong. So what was the idea? Well, you can discuss, it's an interesting thing. Some people used a tutor, some people waited for a teacher to explain and memorize. Some people bought collections of solutions. Don't think that it's invention of our time. Not at all. Not at all. There were collections of solutions for textbooks. Anyway, the idea of problem solving was not that popular. Oops. Another example outside of our continent. So, example quotation from the report of American Commission on Mathematics Education. So they wrote in the textbook of algebra 50 years ago, again, 1911, much more stress was placed on logical exposition than on the solution of problems. Various operations, some like the square and cube root of polynomials having no conceivable use, and other more pedantic elaborations of methods that in simpler form were well worthwhile, were laboriously discussed and exploited before the use of equation in discussing problems was entered upon. So not even problems in this sense, but even simple tasks were very few. And what has happened then? And then we observe a change, not one day change, but change. And you can ask, what has happened? Well, this building, it's an old building of Polytechnic School in Paris. Extremely important educational institution. They had selective exams. And this idea of selective exams influenced not only French education, but education everywhere. And people started thinking, aha, we need to do something. We need to give different kinds of problems. Social things, that much more people were educated. I said that, say, in early 19th century, a student was typically from, I mean, in reasonably privileged educational institution. His parents often hired tutor who solved problems for this person. Then it changed. Already, say, in Russian Empire, it changed somewhere around the end of 19th century, basically around Kiselyov's time. Most importantly, social needs. People faced much more unknown problems. Of course, all these things are in connection. It's not isolated. But anyway, people started thinking and saying that, yes, we need to have some more unusual problems for this or that reason. I would say that this idea developed in 19th century and became quite strong at the end of 19th century. Now, things went further, and already after Second World War, people started understanding that basically some routine work can be done by a machine. And of course, early works on problem solving were in connection with work on artificial intelligence and things like that. Because people start thinking, look, but that's done. It was such a beautiful thing about solving some calculation problems, but nowadays it will be done by calculator or computer and so on. So some important steps which any textbook will mention here, that's Diert Spoyer, great Hungarian scholar, great mathematician and great mathematics educator. And he wrote his book, How to Solve It, which I strongly recommend to everybody who so far had no chance to read it. It's a very small book, so you will do it. He wrote also several large books, but this book, most influential and small, and you can easily read it, and it's extremely important. One of his major ideas there is the idea of heuristic. So basically, the idea is that when you faced new, unknown problem, you should not just sit and cry and say, I don't know, but you need to try to do something. And he suggested several ideas how to do it. Say, try to solve more simple problem, or work backward, that is, start from the end and see how you can get the result, or things like that. So he offered some very important ideas. Was extremely influential. I believe it's #1 in terms of influence. Probably he is, in at least last 100 years, he's clearly the most influential. The book was published after World War II, and it's still very important. I would mention another person, and that's a book of Alan Schoenfeld, who wrote some papers, of course, but there is a book, Mathematical Problems Solved in 1985. And in this book, he brought some new ideas. So he said that there are 4 parameters, 4 aspects of problem solving. So first one, he called resources. Well, it's not just knowledge, but first of all, it's knowledge. So if you do not know Pythagorean theorem, you have no chance to solve problem based on Pythagorean theorem. Simple like that. Second heuristic, so ability to organize your thinking, mathematical thinking. And then two more parameters. So first is control. So you are not just very important things excuse me, connected with the thing which sometimes it's called metacognition. So thinking about your thinking, how you organize your activity. That you think, okay, why I'm doing this? Why I'm involved in this strange calculation? What will I get from them? That you control yourself. And the last is beliefs. You'll say, look, how beliefs relate. Yes, beliefs, it's about your understanding what you are doing in mathematics, what you are doing in mathematical problem solving. And he gave a very good example. If your student developed thinking that problems, that tasks should be solved either in 2 minutes or they cannot be solved, unfortunately, that is what is happening in many American schools. Then you cannot do any problem solving because problem solving is not about 2 minutes. So he brought these 4 parameters again. It's about not only about mathematics, it's about social and psychological parameters. What happens then? Which contribution? Look, it's 85. So 37 years after that. What happened later? Well, a lot of works in many countries on different aspects on mathematical problems. Specifically, a lot of people, of course, wrote about technology, how technology helps to problem solving, what can it give to us. People describe specific of organization of lessons, many parameters. So again, I really cannot even try to discuss all works to make literature review. I would just like, oops, what is going on? Yes, I would just like to cite one work, also of 85, which I really like, and it's an interesting study, both from methodological point of view and from this result. So it's work of Tom Cooney, published in Journal for Research in Mathematics Education, and it's called The Beginning Teacher's View of Problem Solving. So the paper is about the story of one beginning teacher. This teacher was very fond of problem solving. After his college, he really thought, yes, we need to bring problem solving to the school to give them authentic problem solving. So when he came to the school, he always gave students a lot of funny tasks, all kind of puzzles. Every lesson was filled with puzzles. What happened? Kids, and most importantly their parents, found that something wrong. Mathematics lesson is not about solving funny puzzles, how one fly or did something. It's about you are doing some stuff which you need for exams, for whatever. So they were strongly opposed to him. They did not believe in him. Well, just in 3 months, the guy who was beaten and humiliated and made fun of from every side, he said, okay, and returned to what we can call traditional approach. That is the lesson. He explains, today we're doing this stuff, kids are saying, yes, sir, and do this. And what Cooney tries to communicate, that for this teacher, problem solving was an addition to the course. So there is a course, and he tried to add something. Well, these beautiful problem solving. So it was a layer of the pie, not the entire pie. While what we basically are thinking about, we believe that problem solving should be major thing in all courses. It doesn't, of course, exclude exercises and practical training and so on, but it's a major way of delivering the course, as we believe. One theoretical construction. So going for basically more general, there is some rule, some law of semiotics. When we create a new object which takes functions of the old object, for the first time, this object takes the form 2. The most famous example are first cars. As you can see, first cars looked exactly as carriages, because they were taking their functions. Okay, we're doing something like it was, but with different, let's say, machinery. Only later we understand that, look, why car can look absolutely different. So what I just want to emphasize here is a very important thing. As we just discussed, problem solving, of course, was done always, but only very few people were doing it. And when they were doing it, yes, they did extremely sophisticated problems. There were, say, 5 people in the world, probably less, who invented something. Yes, something very, very challenging. Today, we would like basically almost, well, basically everybody to do problem solving, but it doesn't mean that these problems should be same difficult problem as they were before. Functions are the same, but form can be different. And probably the most important thing is some message which we have here, that problem solving is not about gifted kids only, Olympiad problems and things like that. Well, it's great if you made the result and your students are winners of Olympiads, it's great. But it's not the task for all students in the world. But what is the task? We want all students in the tours in the world, ideally, have some experience of facing unexpected situation and doing something with this. That means that it's not isolated episodes. And now, guys, we are doing a bit of problem solving. No, we need to have a lot of experiences in this, how to face unexpected situation. And of course, we need to be very professional, not to make it too difficult. Now, at this moment, I think I'm reasonably okay in terms of time. I want to tell a little bit about the book in which I'm participating now. It's not yet published, and there are always some delays, partly because of pandemic, partly because of other reasons. So the book is supposed to be published in Springer, and book edit is Rosa Lakin from Haifa. And there's 3 sections. And my section is about collections of problems. What I want to say, in reality, in school, we are not solving isolated problems. we're solving collections of problems. It's very important to think how we organize this problem. By the way, by organizing collections, we teach students how to work with isolated problem too, because student is creating, ideally, his or her own collection. And that's the idea of heuristic. That's what Polya said. Let's consider simpler problems. So student himself or herself will create simpler problem, another simple problem, and then we'll come to a difficult one. We need to teach these things. Well, there are some famous collections. I, of course, cannot miss but cite the most famous collection of Polya himself. It's an old collection, but of course, still extremely influential. Here is my favorite book. I enjoyed this book. That's people from Kharkiv who prepared it. And it's translated in many languages. Absolutely fantastic book in my experience, in my understanding. But that's books for, let's say, more advanced students, for college. Regarding school, I, of course, strong proponent of this collection, which was used through entire Russian Empire, and cannot help, I will cite him again, to cite my mentor. You see, when I came to school, I had a really good luck. I had absolutely a fantastic teacher who worked there and who really strongly influenced me. And his name was Aaron Meiseles, and he once jokingly said to me that students somehow identify which problems were given in Rybkin and which were not, and those which were not are too difficult for them. It's a great words about Rybkin. Rybkin, to some extent, managed to make maximum. So it's an example of beautifully constructed textbook, well, collection for this time, of course. You can ask yourself, I do not expect everybody to report, but it's an interesting question for all participants to ask which collections of problems you like most of all. What is your favorite collection and why you like it? Now, construction of a collection, of a sequence of problems. Of course, there is a thing which any teacher must to know how to do. So constructing sequence of problems, preparing, you start with something simple, then a little bit more challenging, then more challenging, and so on. So in this way, a problem which looks like a vertical mountain, you cannot do it. You basically make it a path which students themselves can overcome. So yes, problem solving, still making something unexpected, but with a happy end, successful, so that it's not just that, okay, there is a problem, I don't know what to do. You can give many examples. Of course, a good teacher very often, instead of saying, okay, guys, now go and prove Pythagorean's theorem on your own. Students cannot do it. We'll cut the problem in reasonable pieces of which students can prevail. It will be creative activity with some beautiful experience, but do it. But what I just want to say is that it's not just it. You can, working with collections, you can do much more sophisticated things. Again, here's a portrait of my mentor. We worked basically, I was very privileged to work with him 18 years. We basically managed to publish a small booklet about him. And I was in his lessons where he did, for instance, the following thing. So he gave a problem. At least I should do something mathematically, right? So here is an angle. Here is a point. Construct a straight line through this point so that segment, which will be cut by the angle, will be partitioned in equal parts by this point. It's a very good problem, sophisticated, but class was strong, and I observed that kids are, after some, say 15, 20 minutes, offer some very good solutions. Say two most famous solutions. So one solution, okay, here is an angle, POT, here is a point M. So what you can do, you can construct MK parallel to OT, right? Then you double this OK, you construct KP, KP equals to OK. And then you construct PM until intersection in point T. So you got triangle OPT in which KM is parallel to OT and K is the midpoint by construction. Therefore, PM is equal or congruent, whatever language you prefer, to MT. Done, constructed. Another problem, another solution. You can construct OM, double it, that is MF is congruent to OM, construct FP parallel to OT, and then construct PMT. And you can prove easily that this triangle PFM congruent to triangle TMO, and that's it. Then it's a midpoint of this. Kids offer these solutions and many more. Of course, there is a great temptation to construct the perpendiculars and do something with perpendicular. Kids did it. So many solutions. Beautiful. And then what Ron did, he offered another problem. The problem was, here is a circle and here is a straight line and here is a point. Construct lines such that, again, segment will be partitioned in equal parts. Oh dear, what was going on in the class? Because basically it's the same problem, right? You had two lines. Now you just substituted one line with a circle. But the idea is the same. Okay, just try to do what you did. You cannot. What you're going to extend, what you're going to double. Kids thought they tried to construct tangent line. So that was really, really, really very emotional moment, because looks like everything is there, but you need to invent something. So by organizing just two problems in some order, he received fantastic result. There is one very important author currently in the United States, Harold, his last name is Harold, who wrote that most important thing in problem solving is creation of intellectual need, that students want, they feel that they need to solve the problem. And yes, here was an intellectual need. I leave the problem for the audience if you don't know, because I think it's very, so how, what should you do with this problem? How to solve it? But that's not it. You can organize, it was difficult construction, difficult, challenging problems. But you see, just by given problems in different order, you organize way of thinking of students. Here is an example. First problem. I'm just given two problems or something like that, not going in details. You can give much more. So here is a problem. Check that one is a solution of the problem, of the equation. Second, solve the equation. Okay, what will happen? Well, I cannot predict, but I would say typical. What will happen? Okay, your student will take one, plug it here, 1 squared minus 2022 times 1 plus 2021. Oh, indeed, it's 0. So yes, 1 is a solution. Then you need to solve the problem. Well, typically, I have some data, but Of course, it can be different, but typically a student, if it's a good, reasonably good student, will say, okay, one solution is one, product is 2021, so second is 2021. Or yes, the student can use formularies and solve it like that. So one way of thinking. If you give in another order, solve and then check, it will be completely different intellectual activity. So yes, students will solve by the Vieta theorem or whatever, and they will say, okay, I got one and 2021. Yes, one is among solutions. So it's another activity. It's another train of thoughts. So you in some way organize train of thought and you regulate this train of thought, which is, so it will be students' activity, but influenced by you. Just given more examples, citing basically dissertation, which one my student did years ago already. So what he did, he gave two students, it was in the form of interview. So problem number one, solve the equation. Problem number, I'm sorry, how many solutions has the equation? Problem two, solve. Problem three, construct graph and have an intersection with a straight line. What was going on? Of course, there were strong students who wrote everything, solved it, okay, but very often. The situation was that students, okay, how many solutions? So students were saying two. Why two? Well, because they know that once you have absolute value, they're typically, okay, good, which two? 5 and negative 5, sure. Wait. No, not negative 5. What is it? Negative 1. So 5, negative 1. Good. So trial and error. They just tried. Yes, okay, 2. Good. Thank you. Second, basically the same problem. Solve the problem. What was going on? Students were solving this problem, but they were not very strong with algorithms. Made a mistake, received one solution. So answer X equals whatever 5. Are you sure? Yeah. One solution. Yeah, one solution. In the previous two, in this one. Yeah. Okay. Construct the graph. Again, same story. So basically, you can say, oh, how terrible. They did not learn. Nick Marcantoni is my doctoral student. So what has happened? You can say, look, they did not learn algorithm. How bad? Of course it's bad. Of course it's bad. But the thing is that they see no sense in the process. They were not surprised, but that the same thing basically got different results based on what word way at first, how their assignments was given. What I just want to say, that organizing collections like that, and that's in my opinion the most important problem of our students, that they do not see any sense, they do not connect these things. So organizing collection in some way, you can influence these things. And here is, I'm approaching the end, and I want to make 2 comments. I can go much further in discussion of these sequences, collections, and all these things, but what I just want to say. Let's be honest. We are teaching very often some problems, not because people will necessarily use them, say, in their practical life. It's this favorite question. And when will I use that sine of 30 degrees is 1/2? When will I use it? Well, the answer is typically nowhere, except your exams, of course. But we are teaching, if we're asking, okay, we're teaching not only for exams. Why we're teaching a lot of students, all these things? because most important for us is to teach every student, not just these technical things, but we want to teach the student to work in conditions when not everything is known in advance. So we want students to start to do something, to try something, to understand. Extremely important, guys, here I cannot miss but say that it's one of the most important things for today, to learn how to distinguish truth and lie. What should we say? Oh, you are saying that that's an answer. Is it real? How can I check it? How it's connected with what I was given? So try to do something. Probably the result of activity of a human being will be that, okay, I cannot do it. I need to ask for assistance. In real life, well, it happens. Yes, here is some problem. I don't know how to treat it. I will ask somebody. But that's a great result. It's a great result. People understand that, yes, here is something specific. I need an assistant. Yes, that's what we need. That can be done, again, not only with famous problems. We have collections of famous problems, difficult problems. No, it can be done with basically everything, but we just need to learn, and every teacher needs to learn how to do it, how to create this atmosphere of problem solving. And probably the last thing will be pedagogical. I don't know to what extent this language, teacher-centered education and student-centered education, to which extent it came to Ukrainian literature. In the United States, it's the most favorite words, meaning that teacher-centered is bad and student-centered is good, and teacher-centered education, that's the teacher just gives a lecture, not looking what is going on, just tells his or her stuff. And student-centered, we go from what student want, from their feeling, their interest, and so on and so on. Well, in reality, I believe, despite very good intentions, we all have very good intentions in education, it's a very bad terminology. Because, of course, there is no opposition. Education is about students. I am citing here basically my own experience. I had half of a century ago, I have a teacher who basically loved to give us assignments. It was not in mathematics. He said, you read the book. And she went downstairs to school cafeteria and bought some stuff and did her things. So that was teacher-centered. She thought about herself rather than about students. Guys, it also can be called bad teaching, ineffective teaching, whatever. Of course, student is in the center, but the problem is how we're working with a student, and that can be very difficult. By the way, sometimes can be that, yes, the teacher is talking himself or herself, and it's effective if it's well done. I remember, again, my mentor did it, and people just were listening with open mouths because it was very interesting, constructed very interesting. But in general, teacher organizes the class not by direct assignments, but by constructing sequences of tasks. And that is, again, we're coming to the idea of constructing these sequences, how to think about sequences, how to create these sequences. And so that's also an issue not only of psychological change, not only of social changes in students' mind, but it also about organization of the classroom. That's why I believe these things are very important. Thank you so much for your attention, and I'm happy to take questions at this moment. Thank you so much.
Дякуємо професору Карпу за змістовну доповідь. Я не сказав на початку, але я в чат написав для всіх, що ті, хто мали змогу під час доповіді, якщо у них була така можливість, вони могли залишати коментарі в чаті. Я бачу, що в чаті у нас коментарів немає. Мається на увазі коментарів і запитань. Але при реєстрації на цю лекцію учасники мали змогу задати запитання доповідачу. Ці запитання, якщо вони були англійською мовою, то ми їх в оригіналі зараз задамо. Якщо є доповідачі, то вони можуть уточнити свої запитання після прослуханої доповіді, або модифікувати. Якщо ж вони були написані українською мовою, то ми їх переклали на англійську, і зараз Оксана Олександрівна ці всі запитання нам озвучить. Будь ласка, Оксана Олександрівна.
I'll probably share the screen for you to
Yes.
read them. Yeah.